Hello, everybody. I hope you're having a marvelous Wednesday, and I hope you enjoy this pre-recorded video on lesson 25 using SPSS. As my partners probably just mentioned, a quick reminder, a one-way variance analysis test is a statistical test to determine whether there is a significant difference between the means of three or more independent groups. And that is kind of the golden nugget, three or more independent groups. But there is also other assumptions that lead us down the path of using a one-way variance test, such as number one, the dependent variable is continuous. Two, the independent variable is categorical, having three or more levels. Three, groups are independent of each other. Four, the data is normally distributed. Don't we all wish that, right? And number five, the variance of the groups are equal. So, real quick, in lesson 25, we're introduced with a research study about vitamin C. And as you know, vitamin C is a hot topic, right? Because I don't know if it's you or someone you know, but somebody has been sick recently. For me, it was me last week. I just had to go get a shot. And yes, I did start taking vitamin C. So in this study, the independent variable is the amount of vitamin C taken, and the dependent variable is the difference in number of days with cold symptoms in the first year versus the number of days with cold symptoms in the second year. So that's the independent and dependent variable. And the independent variable is broken down into three groups: the placebo group, control group. And then the second group is the low dose vitamin C group. And then the third group is the high dose of vitamin C group. And the research questions, because the research questions kind of lead us down to what statistical test should we plug into SPSS. So the first question is mean differences. Does the means change in the number of days of cold symptoms differ among the three experimental populations from those who take placebos, those who take low dose of vitamin C, and those who take high dose of vitamin C? The second question is the relationship between variables. Is there a relationship in the population between the amount of vitamin C taken and the change in the number of days that individuals show cold-like symptoms? So let's go ahead and see our data. Let's see what our data tells us. So I'm going to share my screen. I'm using a Mac, and one of the very important things that you need to know when using a Mac is that your tools are up here. So the first step, and I'm literally going by the book, is we're going to press Analyze, and then we're going to click on General Linear Model. We're going to put univariate, which meaning that there is one variable, which here would be the dependent variable on the number of days of showing cold-like symptoms. Here, we're going to put the difference is our dependent variable, and our fixed factor is our independent variable. So I put it over here, and then I put OK, and then I'm going to click on options. And when I click on options, I'm going to put descriptive statistics, the homogeneity test, the estimates of effect, and then I'm going to put OK, continue. And then I'm going to click on the post hoc test, which does a pairwise comparisons between the groups. And here, I'm going to go ahead and put over the groups here, which I have. And then I'm going to do the Tucky test, which the Tucky test is compares the groups and tells us which group is really different from the other groups. And then I'm also going to do the REGWQ test, which is when there's unequal sample sizes of the groups. And then I'm also going to do the Dunnett-C test, which compares all groups from the control group, which is the control group is the placebo group. Okay, and I'm going to click OK, and then I'm going to click OK. And then right here, I put it in the oven and then it came out, right? So as you know, here's our descriptive statistics. Here is the number of participant cases. So here we had 30, our standard deviation, our Levine's test of equity of error variance. So right here. And then we also have our test of between subject effects. So right here, I could already see that our significance is 0.16, which is good, right? Because as we know, 0.05, anything lower than that would be good in order for us to reject the null hypothesis saying that there is no relationship to say that there is a relationship. So 0.5 is kind of the key. And over here are partial eta squared here, the 2.6, is actually really significant as well. And it is considered a strong effect. It indicates that 26% of the variance and the dependent variable is accounted by the independent variable, excluding all other factors. So that's pretty good, like basically that it can be replicated, right? And just as a quick reminder, something that goes into those calculations is our population, and we have to have a very representative sample from our population. Sorry, that's what I meant. That something that goes into our calculation is our sample size, and as we all know, the sample is representative of the population. And then how do we break this down? What we're interpreting into like a visual, nice visual. We're gonna go do graphs. We're gonna do a box plot. And in our box plot, I'm going to put simple, simple for groups of cases. I'm going to define it. Here, the variable, as you all remember was the difference in the number of days. And then the category is our independent variable, the groups. So here, I'm going to go ahead. So here, as you could see, this is the data between the difference in the number of days with cold symptoms between years and vitamin C treatment. So as you could see, the biggest significance was right here that there was this change in 5. Over here, this group also had a very high significance as well. So this is how to use SPSS, and just right now I'm going to show you a PowerPoint on using APA and how to write down our results and make it understandable for the reader and guide them as to why we selected each test. So let's go on. Good. Thank you. Thank you for watching.